Hello and welcome back to Smarter Education's Discrete Mathematics course. Today we will talk about some of the major uses and applications of discrete mathematics. Let's get started. So of course, since discrete mathematics is a field of mathematics, it is useful in the world of pure mathematics. The first example is number theory, which is the study of numbers, the sequences of numbers, and the different types of numbers. A large portion of number theory is studying prime numbers, how they are related, and how they work. Another example is the study of integers, which are non-decimal, positive, or negative whole numbers, and this includes zero. All of these skills then transfer into algebra and calculus, in which an example is shown on the right, where x is a real number. Another field of discrete mathematics is logic, or more precisely, propositional logic. Propositional logic is the study of the truth or falseness of given statements, which can then be used to form sound mathematical proofs. The example on the left is an example of a logical statement, which can be thought about as a true or false mathematical statement, which in this case it is true, because x, which is equal to 5, is greater than 2, but less than 27. The middle statement is a more in-depth example of propositional logic, which uses a concept called Boolean algebra, which we will get more in depth soon. The right is an example of propositional logic that ties into number theory, in which you study how integers, prime numbers, and different types of numbers relate, and if you do certain mathematical functions to them, what happened to them. Another major mathematical concept of discrete mathematics is called set theory. A set can be thought about as a collection or a set of things called elements. The elements in that set are typically numbers which can be determined by certain conditions, such as the set in which x is divisible by 27 or is a prime number. The example, of course, is the set of all prime numbers, which starts with 2, continues to 3, 5, 7, and continues to go up. The example on the right is called a Cartesian product, which can be thought about as cross-multiplying two sets together. Again, you do not need to know how to do these right now. We will get into these subjects soon. Besides the field of pure mathematics, discrete mathematics still has many uses. One of the biggest non-mathematical uses of discrete mathematics is computer science, in which it plays a role in databases, database algorithms, internet search algorithms, cryptography and encryption, Wi-Fi and cellular networks, and more. All of these technologies rely heavily on discrete mathematics, including the very language they speak, binary. We will discuss the binary, the hexadecimal, and different types of number systems later in the course. Discrete mathematics plays an unimaginably big role in the field of engineering. An example of this is discrete time CFD and FEA simulations, hence the name discrete time. If you are unfamiliar with these terms, discrete times refers to a simulation which is done at one point in time and not over time. FEA, or finite element analysis, is a type of computer simulation which measures the strength of engineered parts and is shown on the picture of the left. CFD is a computer simulation which models the flow of air or any other fluids around an engineered part and is showed on the picture on the right. Discrete mathematics also plays a large role in scientific data collection, data correlation, and data patterns. Mathematical relationships, propositional logic, and other discrete math-related subjects play a role in science and data collecting. Some other fields that use discrete mathematics are employee scheduling systems, traffic engineers, and power grid engineers. All of these technologies rely heavily on binary and propositional logic to operate effectively. For example, in an intersection with a traffic light, discrete mathematics is used to determine when a certain group of traffic lights should be turned on and off, and how they should interact with traffic lights down each street. So the next question may be, who should learn discrete mathematics? Well, really everyone should learn discrete mathematics. As many points in people's lives, they will come into contact with a situation in which discrete mathematics greatly helps. The listed professions, along with every single person who graduates high school, should have some exposure to discrete mathematics, which is one of the many areas in which the modern education system sucks because they do not teach that to their students. So with outperforming the modern education system, we will continue teaching the subject of discrete mathematics. The next thing that you will learn, or not really learn, but the next thing that we will go over will be the big picture roadmap for discrete mathematics as we go along each individual subtopic. This video was purely just a big picture overview of the subject. And in the next videos, we will get into kind of more specialized uses for each individual video. Keep in mind, all of these videos in the course will be free, as the education and the whole world should be free and based off of first principles thinking. Thank you for helping Smarter Education fulfill its goal. And if you have any suggestions, please let us know. I will see you in the next video. Bye.